Hello guys, welcome to my channel WinChem. Today we are going to see a chemical kinetics formulas, and it's like a mind map also. It is useful for all the exams. Let's see one by one. What are all there under chemical kinetics? Rate of the reactions and the factors which influencing the rate of the reaction, and integrated rate equations. In the integrated rate equations, all the order of the reactions are mentioned under this heading. And tricks related to the half-life period. What are all the tricks which is useful for the problems that I included in this video, in this slide. And temperature dependence. Temperature dependence means what is the relationship between the Arrhenius equation and the temperature, that is included. Collusion theory of the chemical reactions. Okay, let's see another next one. The first one is rate of the reactions. What is the rate of the reactions? If the A is a one reactant which gives P as a product, okay, then how to write the rate of the reaction for this equation? If A reacted, how we have to write? If the A is a reactant, okay, this gives B as a product. The rate, how to write it, rate means speed of the reaction. We can say this, the speed of the reaction in two ways. One, the decrease in the reactant, okay, concentration of the reactant, or increase in the concentration of the product. In the two ways we can say. So decrease in the concentration of the reactant, in which period of time, okay, that time, okay, divided by time taken, and the increase in the concentration of the product in the period of time, okay, that is called as the rate of the reaction. Okay, that's why the decrease is mentioned in the negative delta of concentration of A divided by the difference in temperature. Okay, difference in time, and this positive shows an increase in the concentration of the product of the B, and that concentration divided by its time taken. How much time taken to complete the product formation? How much time taken to decrease the reactant? So that's why that is mentioned in the form of rate. Okay, speed of the reaction. The unit of the speed of the reaction is mole liter inverse second inverse. Okay, what are the factors which influence this rate of the reaction? Okay, for example, here I have taken only one reactant which gives one product. Okay, here the two reactants are there. This is also one of the reaction. What are the factors which influencing the rate of the reaction? First one is the concentration of the reactant. This is the concentration we have mentioned like in the square bracket. This is the concentration of A and B. That is the one factor which influences the rate of the reaction, speed of the reaction. And how to write under the concentration of the reactant, these are all things are there. They just I want to include it. That's why I mentioned in here itself. Okay, rate expression. How to write the rate expression means the rate which is proportional to the a to the power of x and a to the power of y. This x and the y is order of the reaction. If you sum up the x plus y means that is order of the reaction. Okay, the rate constant is, if the proportionality is removed means we have to include the k. That is the rate constant. This is the rate constant. These are all the important names which we should know. That's why I mentioned over here. The next factor which influences the rate of the reaction is temperature. First one is concentration, a temperature, a catalyst, nature of the reactants, and the exposure to the radiations. These are all the 5 important factors which influence the rate of the reactions. If the rate of the reaction increases means by increasing the temperature it will increases, and in the same way the catalyst also it increases the rate of the reaction, but at the same time it lowers the activation energy. The catalyst which lowers the activation energy, and we are going to see about this activation energy and temperature in the next slide. Okay, that's why I don't want to mention over here. And the next one is integrated rate equations. What is the integrated rate equations? I already said what is the rate and the rate constant, everything I said. That we need to write it in an equation form. That we call it as integrated rate equations. The integrated rate equations varies for the order of the reaction. For example, if the order of the reaction is 0, what is the order of the reaction? I already said if you add the x plus y, that is the order of the reaction. If the order of the reaction is 0, then the rate is equal to k. The rate constant, how to write it? K is equal to 1 by T A naught and A. That is concentration of A naught and concentration of A. So, and the T half, that is T half means half-life period of half-life period. Okay, half-life period T half is equal to A naught divided by 2K. This will vary according to the first order reaction and second order reaction. This is 0 order reaction. Okay, this we call it as an order of the reaction. So according to this, we are going to write the rate, integrated rate constant, integrated rate equation, and the rate constant, and the half-life period. I don't want to derive all the equations. First, these 3 equations is very important to solve all the problems. That's why I included this. Okay, and the next one, What is the tricks in the for the half-life period? What is the related tricks is there? See, if you see what is the half-life period, that we need to know first. Okay, half-life period means half of, if you take 100 grams of 100 percentage of the reactant, okay, after some times it will move to the half of the reactant is over. Then what we are saying, 50% of the reaction is over. Then that we call it as a half-life period. Okay, half of the reaction is over. That we call it as half-life period in a time of half minute. Okay, half of the time. That we call it as half-life period. See here, if you take 100, okay, we assume this as a 100% of the reactant. Okay, after some time, that is the half of the reaction. Okay, what will be have? It becomes 50 of the product is formed. The remaining 50 is as it is. Okay, the 50% product is formed. So this is a 50% completion is 50% completion. The 50% completion is the first half-life, and the next 50% completion is 75% completion is there. Actually, second half is 75% completion. In this 50 half means 25. That is overall, if you see, that is 75% completion. So this percentage we should know according to the half-life. The first half 50%. If you take the second half, that is 75%. If you take the third half, that is 87.5. In the 25, in this 25 half, you have to take it. That is 12.5. So overall, if you calculate from here, it is 87.5. Like this. This trick is easy to solve the problems. So I mentioned over here. If you see, that is 3/4 of the reaction. That is 75% of the reaction is second half-life period. And third half-life period is 87.5. And fourth half-life is 93.75. And fifth half-life is 96. Like this, 100% means it is nearly 10th half-life. Okay. And another thing which I would like to mention, and the last equation I have mentioned in that equation, how to write it after the 1 half-life divided by 2. Only 2 I have to mention. It is a 1 half-life means. If it is a 2 half-life, amount of the substance which is left after 2 half-life means 1 more 2 you have to include. How much is the 2 is there? So 1 more 2 you have to include. So 2 power 2. So another 3 half-life, it becomes 2 into 2 into 2. So 2 power 3. So according to this, how much half-life? After 3 half-life means 2 power 3. If it is n half-life means 2 power n. So this is a general formula. It is useful for solve the problems. This one. This is EA is the activation energy. If you plot a graph between the log K and the temperature 1 by T, if you can get the straight line. The slope of this is equal to 2.303, 1 by 2.303 into R. This is useful to determine the activation energy. Then we will see what is activation energy. Activation energy, see here, this is the graph, the energy and the process of the reaction. See, the activation energy means, what is that? That is the threshold energy from the beginning till the end. Okay, this is the threshold energy minus of the average kinetic energy of the reacting molecules. If you see, this is the threshold energy minus of this is the average, this one. Kinetic energy of the reactant. It may be HR, means it may be enthalpy of the reactant or potential of the reactant or energy of the reactant, whatever the term you can use it, but this is the energy level. Okay, minus of this, it shows the activation energy. This is the activation energy of the forward reaction. The activation energy of the backward reaction means a threshold energy minus of product. Okay, product of the enthalpy of the product or energy of the product or potential energy of the product, whatever we can say that say for this one. Okay, if you minus this, you can get the activation energy of the backward reaction. What is the difference between exothermic and the endothermic? The delta H, this is called as a delta H. The delta H, which is equal to forward, the activation energy of the forward minus the activation energy of the backward. That is the delta H, that is enthalpy change. Enthalpy change is equal to activation energy of the forward minus the activation energy of the backward reaction. If the delta H is less than 0, then this is exothermic reaction. If it is less than 0 means then this is an exothermic reaction. If it is greater than 0, then it is an endothermic reaction. This delta H is greater than 0. So it's an endothermic. This is the difference between the endothermic and the exothermic reactions. So how to calculate, I already said. This is the threshold energy and this is the activation energy of the forward reaction, activation energy of the backward reaction. This is the enthalpy of the reactant and enthalpy or energy of the reactant and the energy of the product. Okay, according to that we need to calculate the activation energy. we need to find the difference with the help of the threshold energy. How to find the threshold energy? Threshold energy is a reactant molecule is there. Initial potential energy of the reactant molecules plus the activation energy. If you add the initial reactant potential energy, that's why I said, this is the potential energy, or you can say the enthalpy of the reactant or energy of the reactant, whatever the term you can use it. Okay, this one plus the activation energy. If you add these two, you will get the threshold energy. So these are all the terms which is helpful for the problems. Make use of it. And the collusion theory. What is the collusion theory? The number of collusion per second per unit volume of the reaction mixture, which is called as a collusion frequency, is Z. Okay, that we call it as collusion frequency. Thus, the rate, the rate depends upon the two factor, which is first one is energy factor, another one is orientation factor. What is the energy factor? The energy factor is the rate which is proportional to the collusion frequency and the Boltzmann factor, that is E is e power of EA minus RT, EA by RT, that one. That is a Boltzmann factor, we can say. Okay, so the rate constant K, which is equal to the collusion frequency, which is Z, into the Boltzmann factor, that is energy factor, minus EA by RT. These two we call as the energy factor. So this is the equation for the collusion theory. And one more term which are included into that, that is the orientation factor. If the reactant, it should be oriented in a proper manner. If it is oriented in a proper manner and the collusion takes place in a proper way, then the product will be formed properly. If it is not oriented in a proper way, there's a steric effect is there, then it will not be react properly. Okay, then it will be as it is. The reactant will be as it is. Okay, that's why I mentioned over here, if this is the A and B and the collusion properly, okay, proper collusion takes place between the A and B and it forms the product. Okay, this is the product AB, like that it will form. Collusion will take place and it will form like this. And if it is not oriented properly, then what will happen? If directly it will go and oriented like this, it won't be react properly with the B. Then the product will not be formed properly. So that's why they are mentioning here as a orientation factor, as a steric factor. Okay, the steric factor which is called as here P, which is called as P. So he see the same thing. The collusion frequency is there. The Boltzmann factor is also there. With that, the orientation factor is steric factor. Here the energy factor. Here the energy factor is Boltzmann factor. Here the orientation factor is steric factor P. So thanks for watching. Subscribe my channel, click the bell button and share to your friends.